Hello everybody. Today we're going to be talking about population ecology, and for today we're going to apply these concepts to populations of animals, and then a little bit later we're going to apply these concepts to the human population. So we're going to start off by quickly reviewing some concepts that you should already know from biology, and then move on into some new stuff. So before we get started, here are today's lesson objectives. So these are the things that you should be able to know or do by the end of this video. And remember, these are fair game for the quiz at the beginning of class tomorrow. So a population is a group of individuals of the same species that live in the same geographic area. So an example of that might be black bears that live in eastern North Carolina. So as you can see, in North Carolina, we have two different populations of black bears, one in the western part of the state and one in the eastern part of the state. So all populations need four things. They all need food, water, and shelter, which are the requirements for the individuals in the population. And then a population also needs space. Population size is the number of individuals in a population. This is influenced by four things: births, which positively affect or cause population growth; deaths, which negatively affect the population or cause a population decline; immigration with an I, means that individuals are coming into the population. So I is for in, and that's positively affecting or causing population growth; and emigration with an E for exiting, so individuals are exiting the population when they emigrate. So it's a negative effect on the population. And before we move on, I just want to make sure that we're all aware that deaths is a pretty broad category. It encompasses a lot of individual events that we just lump together and call deaths when we're doing math for population size. So this might include disease that killed some animals, or maybe a natural disaster that came in, or hunting or fishing pressures, or all sorts of things like that. All right, now we're going to talk about graphing our population size. And so we're talking about a change over time. So with any change over time, we're going to use a line graph. And we have to remember that time always goes on the x-axis for graphs. So the first thing we do is we plot our data, plot the population size according to the number of individuals at a given time. So let's say in 1950 we had a population of 100, and then in 1960, 200, 1970 the population maybe jumps up to 400, 1980 it jumps up to 800, and so on and so forth until we get a nice little curve, and then we're going to connect all of our dots. All right. Okay, so in our graph, now we can analyze it. So we can see here that our population is growing. And we can tell that because the population is increasing over time, and we have a positive slope to the line. And then over here we have a declining population, where the slope of the line is negative. And then over here, where our slope of the line kind of evens out, it kind of goes back and forth, but it kind of evens out around this area. This is a stable population. And this is what we call our carrying capacity. So our carrying capacity for this population is about 700. So this is our carrying capacity. All right. And so carrying capacity, as we just kind of alluded to, is often represented by the letter K when we're doing mathematical equations with it. And it's the number of individuals that the environment can support in a given area. And so, as we see over here with our graph, populations kind of tend towards a carrying capacity, but they might not end up at one single carrying capacity. So you can see here in our population, it kind of fluctuates between about like 750 and 650 individuals over time. So we call our carrying capacity 700 because it's right in the middle. And so unless a population is facing some imbalances or some stresses or an extremely large amount of resources, it's going to tend towards that carrying capacity. Some possible imbalances that a population could experience are some negative stressors from the environment. So one could be overhunting or fishing, like the bluefin tuna has experienced. So you can see from 1960 to 1992, their populations fell drastically because of fishing for the sushi industry. Another negative impact might be chronic disease or infestation, like the woolly adelgid. So this is a bug from Asia that causes this woolly kind of growth on the hemlock trees, and it's killing the hemlock trees a lot faster than they can grow back. And another one might be declining resources. So our friend the polar bear, which we've all heard about, so the ice is melting where the polar bears both live and hunt, and so their habitat is their declining resource that causes their population to decline. So whenever we see a declining population, we're going to see a negative slope in the graph over time. And then some positive things for population growth might be that there are unlimited resources, or there are no predators or competitors for that animal. So a good example of this is the fire ant in the southeast. So you can see that the fire ant's population started here in Alabama, and then it's spread both east and west and north. So the fire ant is originally from Argentina, so it doesn't have any predators or competitors here in the United States. And so their population graph might look like this over time. It's constantly increasing. All right, so now we've covered the basics of carrying capacity and population size. And so tomorrow in class, we will do an interactive activity that will get us a little bit more experience.